Our universe might be a flawless illusion. We are about to examine 25 bizarre space theories that challenge the very foundations of reality. By the end, your understanding of existence itself will be profoundly unsettled. We will confront the possibility that our cosmos is a simulation and question if time is even real. What do you truly believe about the world around you? The very fabric of reality might be a lie. This is the core of the simulation hypothesis, the idea that everything we see, touch, and experience is not base reality, but an incredibly advanced digital construct. Think of it as the universe's most immersive video game, and we are the characters inside it. This concept is far older than modern computing. Over 2,000 years ago, the philosopher Plato described prisoners in a cave who mistook shadows on a wall for the real world. He questioned if our senses could ever be trusted to reveal true reality. The simulation hypothesis is a technological update to that ancient suspicion. In our time, thinkers like Nick Bostrom have formalized the argument. He proposes that a future civilization with immense computing power might run vast numbers of detailed simulations of its own ancestors, just as we run historical simulations today. If that is true, then the odds are staggering that we are living inside one of those countless simulations, rather than in the original biological past. But how could we possibly know? Proponents look for potential glitches in the matrix, subtle errors in the code of our universe. These might appear as unexplainable constants in physics that seem finely tuned, like the speed of light, or as quantum particles that behave in bizarre, probabilistic ways only when observed. It is as if the simulation is rendering reality only where we are looking to save processing power. Visualize a digital grid subtly superimposed over a swirling galaxy, or lines of cascading code forming the spiral arms of a nebula. The unsettling question is not just whether we are in a simulation, but what happens if we ever find definitive proof. The ground beneath our feet, the stars above, even the flow of time itself could all be part of an elaborate program. If reality is a simulation, then what is it projected onto? This leads us to a theory just as mind-bending, born not from philosophy, but from the cold, hard math of black holes. It is the holographic principle, and it suggests our three-dimensional universe with all its depth and volume might be a magnificent illusion painted on a distant, two-dimensional surface. Think of a credit card hologram. That shimmering, three-dimensional eagle is not really there. It is encoded on a flat, plastic sticker. The holographic principle proposes our entire cosmos works the same way. All the information that makes up you, me, the planets, and the stars could be written on the outermost boundary of space, like data etched onto a cosmic DVD. The science behind this starts with a paradox. When an object falls into a black hole, it seems to vanish, destroying all information about itself, which violates a fundamental rule of quantum physics. In the 1970s, physicist Jacob Bekenstein calculated that a black hole's entropy, which is a measure of its hidden information, is not proportional to its volume, but to the surface area of its event horizon. It was as if all the data about what fell in was smeared onto that spherical shell. Decades later, Leonard Susskind and others expanded this idea, arguing the universe itself might obey the same rule. The information needed to describe everything within a region of space could be fully contained on its surrounding surface. In this view, the three-dimensional world we move through is a projection, a holographic read out of that underlying two-dimensional data. What does this mean for us? If true, it implies our experience of depth, solidity, and space itself is a kind of convenient fiction. Your perception of being here, in this moment, moving through a voluminous world, is an incredibly convincing rendering of data stored somewhere else on the cosmic equivalent of a flat screen. This challenges the very grain of reality. It suggests free will could be the experience of a complex calculation unfolding on that distant boundary, and that space-time may not be fundamental but emergent, like the image on a movie screen. One profound mystery remains, however. If our reality is a projection, what or who is the projector? The projector might be a cosmic accident. This brings us to a theory so unsettling it questions whether the universe or even our own minds are real in any lasting sense. It is the Boltzmann brain paradox, a thought experiment that emerges from the deep laws of thermodynamics. These laws state that systems naturally move from order to disorder, a process called entropy. Yet, they also allow for the opposite, for random fluctuations that create pockets of order out of chaos. Given enough time in an endless, empty void, the mathematics suggest a bizarre possibility. It becomes more statistically likely for a single, fully formed, self-aware brain to spontaneously assemble from random particles, complete with false memories of an entire life, than for our vast, complex, and ordered cosmos to naturally evolve. Picture a lone human brain, adrift in the infinite blackness of space, with no body, no stars, and no past. It flickers into existence for just a moment, believing itself to be a person living on a planet called Earth, recalling a childhood, relationships, and watching videos about space. Then, just as suddenly, it dissolves back into the random chaos from which it came. That isolated brain is what physicists call a Boltzmann brain. The paradox forces a brutal confrontation with probability. If our universe is truly infinite and eternal, then these random fluctuations should happen. In fact, they should happen far more often than the emergence of a stable, 14-billion-year-old universe like our own. So, by the raw numbers, you and I are far more likely to be momentary Boltzmann brains hallucinating a consistent reality, rather than beings in a real, enduring cosmos. This injects a profound doubt into cosmology. If our most careful observations of galaxies and cosmic background radiation could just be a detailed fantasy conjured by a disembodied mind, how can we trust any scientific measurement? It casts a shadow over every memory, every recorded history, every piece of data we have. The theory is not widely accepted as a description of reality, precisely because it makes science itself impossible. But it remains a powerful logical ghost, a reminder that our most basic assumption, that the world outside our minds exists independently and consistently, is an article of faith that even physics must ultimately accept on trust. The loneliness of that single brain in the void echoes a deeper fear that all connection and history might be a fleeting illusion. This profound doubt about a single, consistent reality finds a startling answer in another theory, one that does not just accept every possibility but declares them all equally real. It is the many worlds interpretation of quantum mechanics, and it proposes that the universe is constantly splitting into countless copies of itself. Forget the famous thought experiment of Schrödinger's cat, simultaneously alive and dead in a box. That paradox suggests a single, undecided reality. Many Worlds offers a far more extravagant solution. It says the moment you open that box, the universe does not choose one outcome. Instead, it splits in two. In one new, branching reality, you find a living cat. In another, completely separate reality, you find a dead one. Both views are real, both experiences are genuine, and both timelines continue forward independently. This is not about chance, but about certainty. Every tiny quantum event, like the decay of a single atom, triggers a new fork in the cosmic road. Every choice you make, from a major life decision to the random path of a photon, spawns new universes where every alternative version of that event plays out. The scale is incomprehensible. Right now, as you listen to this, an infinite number of alternate versions of you are living out the consequences of every different choice you could have made this morning. There is a universe where you turned left instead of right, a universe where you said yes instead of no, and a universe where the very laws of physics are slightly different. This leads to a deeply unsettling thought experiment known as quantum suicide. Imagine a device is set up that, based on a random quantum event, will either kill you or spare you each time you press a button. From the perspective of a single reality, this is a fatal game of chance, but from the many worlds view, something bizarre happens. Every time you press the button, the universe splits. In one branch you die, but in the other branch you live. From your own subjective experience, you would only ever find yourself in the sequence of branches where you continue to survive. To you, it would seem as if the device miraculously fails every single time, granting you a form of immortality through sheer probability. This is not a recipe for recklessness, but a stark illustration of how this theory reframes existence. You are not a single thread of consciousness, but a near-infinite tapestry of selves, each living a complete and valid life in a separate, uncontactable universe. The loneliness of the Boltzmann brain is replaced by an overwhelming cosmic crowd, where every regret is soothed by the knowledge that somewhere, another you made the other choice, and every triumph is humbled by the realization that it is just one path among an endless sea of alternatives. If this is true, then reality is not a single story, but a library containing every story that could ever be written. That infinite library of branching realities operates on one unbreakable rule: information can never be truly destroyed. This sacred principle of quantum mechanics now collides with the most destructive objects in the cosmos, creating a paradox that threatens to unravel physics itself. It is the black hole information paradox. The conflict is stark. Albert Einstein's theory of general relativity describes black holes with beautiful simplicity. Their immense gravity creates an event horizon, a point of no return. Anything that crosses this boundary, whether a star, a spaceship, or a book, is lost forever, crushed into the singularity at the center. The information about what that object was, the arrangement of its atoms, the story it told, is erased from our universe. Quantum mechanics, the rules governing the very small, declares this impossible. In the quantum world, information is eternal. You could burn a book to ashes, but in principle, if you could collect every particle of smoke and heat, you could reconstruct every word. Information might be scrambled, but it is never lost. So what happens when a book falls into a black hole? One set of laws says it is gone, the other says it cannot be. For decades, physicists hoped Stephen Hawking had found a way out. He discovered that black holes are not completely black. Due to weird quantum effects at the very edge of the event horizon, they slowly leak radiation. This Hawking radiation carries energy away, causing the black hole to shrink and eventually evaporate completely. But here is the catch: Hawking radiation appears to be purely random, like thermal static. It carries no information about what fell in. So when the black hole finally vanishes, all the information about everything it ever consumed vanishes with it, violating quantum law. This is the paradox in its purest form. To solve it, theorists have proposed solutions that sound like science fiction. One idea is the firewall paradox. If information must escape, perhaps it does so in a blazing wall of ultra-high-energy particles that incinerates anything crossing the horizon. This saves quantum mechanics but destroys Einstein's smooth, uneventful fall into a black hole. Another, more elegant solution returns us to the holographic principle. Perhaps the information of the fallen book is not lost inside the black hole at all. Instead, it is perfectly preserved, encoded in a scrambled, two-dimensional form on the surface of the event horizon itself, like a cosmic holographic sticker. The three-dimensional book is gone, but its complete blueprint remains, painted onto the sphere from which no light escapes. Hawking radiation, then, might not be random. As the black hole evaporates, this stored information could be slowly and subtly imprinted onto the escaping radiation, like a message being transmitted in a cosmic whisper. The book is translated into a code on the horizon, then broadcast back into the universe particle by particle. If this is true, then black holes are not ultimate shredders. They are the universe's most extreme archivists, compressing three-dimensional reality into a two-dimensional fossil record on their skin. The event horizon becomes a palimpsest, a surface etched with the stories of everything it has ever consumed, waiting to be told again through the faint glow of its own demise. This struggle over a single bit of lost information reveals a crack in the foundation of reality, a place where our two best descriptions of the universe directly contradict each other. Solving it may require a revolution in physics, one that forces us to ask what reality is made of in the first place. That cosmic whisper of information escaping a black hole hints at a deeper connection, a symmetry so perfect it turns destruction into creation. This is the white hole, a black hole's theoretical twin in reverse. While a black hole's gravity is so intense nothing can escape its pull, a white hole would be a region of space from which nothing can enter. It would violently expel matter and energy in a perpetual one-way eruption. If a black hole is a cosmic drain, a white hole is a cosmic fountain, gushing material outward at the speed of light. For decades, these objects were considered mere mathematical curiosities, impossible solutions to Einstein's equations that could not exist in the real universe. But what if our entire reality is the proof they do exist? A radical theory suggests the Big Bang itself was not a singular, inexplicable beginning, but the explosive birth of a white hole. In this view, our universe did not emerge from nothingness. It was ejected somewhere in a vast and ancient parent cosmos. A supermassive black hole collapsed into a singularity. But instead of ending there, that singularity tunneled through the fabric of space-time and erupted elsewhere as a white hole, spewing out all the matter and energy it had consumed in a cataclysmic fireball. Our Big Bang in this scenario was that eruption. Every galaxy, every star, every atom we see is the recycled material from another universe's demise. This transforms the cosmos from a one-time event into a link in an eternal chain. It supports a cyclical model of the universe often called the Big Bounce. In this grand vision, universes are born from the death throes of their ancestors. A black hole in a parent universe collapses, rebounds as a white hole to create a new universe which expands, forms its own black holes, and eventually those black holes seed the next generation of cosmic offspring. We could be living inside a cosmic Russian nesting doll, a universe within a universe with our own black holes serving as portals to future realities yet to be born. Picture the moment of creation not as a silent spark in a void, but as a violent, brilliant geyser of fundamental energy, tearing a hole in the fabric of a pre-existing reality and flooding a new domain with the raw ingredients for galaxies. This theory elegantly solves the mystery of the Big Bang's origin by giving it a physical cause, a cosmic inheritance. It suggests that the laws of physics in our universe are not random, but were shaped by the specific conditions of that parent black hole's collapse. We are not just star stuff, as the saying goes. We are the carefully processed remains of an entire cosmos that came before. If true, then every black hole we observe is not a final grave, but a potential womb for a new reality, a universe in waiting where the arrow of time runs backward and creation begins anew. But what if that cosmic chain of birth and rebirth is destined for a far more violent end? The engine driving our universe's expansion is not a gentle push, but a force with the potential for ultimate destruction. We call it dark energy, a mysterious presence that makes up about 70% of the cosmos and acts against gravity, causing space itself to stretch at an accelerating rate. For now, this expansion is gradual, carrying galaxies away from each other like dots on an inflating balloon. But dark energy might not be constant. Its most extreme and terrifying form is known as phantom energy. Unlike ordinary dark energy, phantom energy's repulsive force does not stay the same. It grows stronger over time. Its density increases as the universe expands, creating a runaway feedback loop of repulsion. Think of it like a car whose accelerator pedal gets stuck and then begins pressing itself down harder and harder with no limit in sight. If phantom energy is real, then the fate of the cosmos is not a slow fade or a gentle contraction. It is the Big Rip. In this scenario, the ever-intensifying force of phantom energy would eventually overcome every binding force in the universe, not just the gravitational pull between galaxies. First, the cosmic threads holding galaxy clusters together would snap. Then, individual galaxies would be torn apart, their stars flung into the ever-widening void. As the phantom energy grows still stronger, it would attack solar systems. The gravitational grip of a star like our Sun would be no match for the stretching of space itself. Planets would be ripped from their orbits and hurled into darkness. In the final moments, the force would reach down to the smallest scales. Stars and planets themselves would be shredded. The nuclear forces that hold atoms together would fail. Protons and neutrons would be torn apart from each other, and even the fundamental particles within them would be separated by the infinite stretching of space. The universe would end not with a bang or a whimper, but with a silent, absolute shredding of reality's very fabric. All that would remain is an endless, empty, and ever-expanding void, where the distance between any 2 points becomes infinite in a finite amount of time. This is not a distant, abstract fear. If phantom energy exists, some calculations suggest this catastrophic end could occur in as little as 22 billion years from now. While that is an almost incomprehensible timescale, it is a finite deadline written into the laws of physics. The clock is ticking on a countdown to dissolution, where every structure, every memory, every atom is destined to be pulled apart into nothingness. The serene image of an expanding universe transforms into a vision of cosmic violence, where the vacuum of space itself becomes an unstoppable engine of annihilation. The absolute shredding of reality in a Big Rip offers one bleak vision of a final end. But what if, for your own consciousness, no final end ever truly comes? The many worlds interpretation of quantum mechanics births a deeply personal and unsettling corollary known as quantum immortality. It proposes that your subjective experience of existence is tethered, not to a single body in a single universe, but to the continuous strand of probability where you remain alive. In the infinite branching of the multiverse, for every possible fatal accident, illness, or disaster, there is at least one timeline where, through an improbable twist of fate, you survive. Your conscious awareness, according to this theory, would inevitably follow that path. Think of it as a cosmic game of chance where you only ever perceive the winning rolls. Imagine a version of you steps off a curb and is struck by a bus. In that moment, the universe splits. In one branch, a tragedy occurs, but in another, a gust of wind, a shouted warning, or a momentary hesitation causes the bus to miss by a fraction of an inch. The you in that branch continues on, slightly shaken but alive. From your first-person perspective, you only experience the sequence of events where you did not die. You recall the near miss, the surge of adrenaline, but not the alternative outcome. Now extend this to every potential mortal danger across a lifetime, from childhood illnesses to old age. In the vast multiverse, there is always a branch where the heart attack is less severe, where the cancer goes into spontaneous remission, where the falling object veers just enough to the side. Your consciousness, like a thread weaving through an infinite tapestry, navigates this labyrinth of possibility, always finding the route that continues. This leads to a bizarre and lonely thought experiment. As the decades and centuries pass in your branching timeline, you would witness the natural death of everyone you know, while you, through an unbroken chain of quantum survivals, persist. You might find yourself living in a future utterly alien, having cheated death so many times that your continued existence defies all biological odds. The universe around you would appear increasingly improbable as you subjectively experience one in a trillion escapes over and over again. The philosophical ramifications are profound. It challenges the very meaning of death, suggesting it is not an event you ever personally encounter, but merely something that happens to other versions of you in branches you no longer inhabit. It turns mortality from a certainty into a spectator sport you only watch from the sidelines of other timelines. Yet this form of immortality is not a blessing but a potential curse. It offers no vitality, just the relentless continuation of awareness. You would not be a vibrant, ageless being, but a statistical anomaly clinging to existence in a cosmos that seems to conspire to keep you conscious at all costs. The theory ultimately forces a question about the nature of self. Are you the collection of atoms in one body, or is your true identity this unbroken thread of perception, surfing the wave function of survival across an endless sea of dying worlds? It suggests that at the core of experience is not a body, but a point of view that fate itself cannot extinguish, forever finding the one branch where the story does not end. This eerie form of persistence hints that consciousness might be more fundamental than we think, a notion that leads us to an even grander and more controversial idea about the cosmos itself. That unbreakable thread of consciousness forever finding a path through the multiverse suggests a universe more connected than we can see. But what if the entire cosmos is being pulled, a single thread in a tapestry far larger than our own? Astronomers have discovered something that should not exist, a mysterious current in the sea of galaxies they call the dark flow. By carefully mapping the motion of hundreds of massive galaxy clusters, scientists found they are not moving randomly. Instead, they are all streaming together at incredible speeds, over 2 million miles per hour, toward a single point in the distant cosmos. This is not the general expansion of the universe, which carries galaxies apart like leaves on a receding tide. This is a directed river of matter, as if some immense, unseen force is tugging on the fabric of space-time itself. The source of this pull lies far beyond the edge of everything we can observe. Imagine standing in a vast, dark field and feeling a steady wind, but every tree, every blade of grass is leaning in the same direction, pointing toward a storm that exists over the horizon, completely invisible to you. That is the dark flow. Maps of the cosmic microwave background, the afterglow of the Big Bang, reveal this subtle but consistent directionality, like a fingerprint of this cosmic drift etched into the oldest light in existence. So what could possibly exert such a titanic gravitational pull from outside our observable universe? One breathtaking possibility is that we are feeling the influence of another universe entirely. In the multiverse theories born from cosmic inflation, our universe may be one bubble in a frothing sea of other bubble universes, each with its own laws of physics. If another one of these cosmic bubbles passed close to ours in the higher dimensional bulk of reality, its sheer mass could be dragging our galaxy clusters toward it. We would be like fish in a pond, sensing the currents caused by a giant moving in the adjacent lake, unable to see the creature itself. Another explanation points to a relic from our own universe's explosive birth. During the inflationary epoch, a fraction of a second after the Big Bang, space expanded faster than light. It is possible that this hyperstretch left behind imbalanced regions, colossal structures of primordial density so vast they span beyond our cosmic horizon. The gravitational attraction of one of these near-mythic structures, a super-great attractor of incomprehensible scale, could be the anchor for the dark flow. This mystery forces us to confront a humbling truth. The entirety of our observable universe, over 90 billion light-years across with its 2 trillion galaxies, might not be the whole story. It may be just a local neighborhood, one that is currently sailing through a wider ocean of reality, drawn by a destination we cannot see and may never reach. The serene, isotropic universe we thought we understood has a current, and we are all caught in its flow. This cosmic current pulling us toward an unseen horizon makes our universe feel vast yet strangely empty. Where is everybody? This is the haunting core of the Fermi paradox, the glaring contradiction between the high probability of alien civilizations and our total lack of evidence for them. Given the billions of stars and planets in our galaxy alone, many older than Earth, the silence is deafening. One answer to this great silence is not about distance or technology, but about intention. It is called the zoo hypothesis. This theory proposes that advanced extraterrestrial civilizations are not just out there, they are fully aware of our existence. They have placed Earth inside a kind of cosmic quarantine, a planetary wildlife preserve where humanity is left to develop or destroy itself without outside interference. Think of a team of scientists observing a rare ant colony through a one-way glass. They watch as the ants build their tunnels, wage their wars, and develop their complex social structures. The scientists do not tap on the glass. They do not drop food into the colony or try to communicate. Their most important rule is non-interference, to avoid contaminating the experiment or disrupting the natural course of evolution. In this view, our solar system sits inside an invisible bubble of enforced isolation. Any signals we broadcast may be carefully filtered or blocked from reaching the wider galactic community. Any probes we send out might be quietly monitored and contained. The occasional, unexplained UFO sighting could be likened to a zookeeper momentarily stepping into view, a fleeting glimpse of the caretakers before they remember to stay hidden. This hypothesis resolves the paradox by suggesting the silence is deliberate. We are not being contacted because we are being protected or perhaps studied. It implies a galactic culture with a unified ethical framework so advanced that it prioritizes the natural development of nascent species over curiosity or conquest. There would be no need for a prime directive. It would simply be the law. This transforms the night sky from an empty frontier into a gallery of one-way mirrors, with countless unseen eyes watching our every struggle and triumph. It casts human history in a chilling new light. All our wars, our art, our scientific discoveries, and our self-inflicted crises might be meticulously documented in some interstellar archive, a reality show for an audience we cannot perceive. The ultimate test may not be whether we reach the stars, but whether we can mature enough as a species to earn an invitation to leave the cage. The zoo hypothesis offers a universe that is far from lonely, but one in which our cherished notion of cosmic significance is replaced by the humbling status of a specimen. It suggests we are not masters of our destiny, but residents in a garden we did not plant, waiting for the gardeners to decide if we are worth talking to, or if we are simply too dangerous to ever set free. That unsettling feeling of being watched from beyond a one-way mirror raises a deeper question about the watchers themselves. What if consciousness is not a mere byproduct of brain chemistry, but a fundamental feature of reality woven into the quantum fabric of the cosmos? This is the radical proposition of quantum consciousness, specifically the orchestrated objective reduction theory, or ORCH, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their idea challenges the standard model that the brain is a classical computer, with neurons simply firing like biological switches. Instead, they propose the seat of consciousness lies much deeper, within the tiny scaffolding of our brain cells in structures called microtubules. These are protein filaments that act as the cell's skeleton and transport system. Penrose and Hameroff suggest these microtubules are not just structural. They are quantum computers. Inside them, electrons can exist in a state of superposition, being in multiple places at once until a specific threshold is reached and they collapse into a single state. This collapse, they argue, is not random. It is orchestrated by the geometry of the microtubules themselves, and each collapse corresponds to a moment of conscious experience, a flicker of awareness. Think of it like the individual frames of a movie. Each quantum collapse is a single frame of conscious perception, and the rapid sequence of these events creates the smooth, flowing stream of thought and sensation you experience right now. The most profound implication is where Penrose looks for the source of this orchestration. He believes the answers lie in the most mysterious frontiers of physics, at the intersection of quantum mechanics and gravity. He suggests that the collapse of these quantum superpositions in the brain is tied to the very structure of space-time geometry. In essence, each moment of conscious awareness is a tiny ripple in the fabric of the universe itself. This theory elegantly bridges the gap between mind and cosmos. It suggests our consciousness does not emerge from the brain so much as it is a process the brain taps into, like a radio tuning into a broadcast. This could explain elusive phenomena like intuition, the non-algorithmic nature of human understanding, and even the hard problem of consciousness, which asks why we have subjective experience at all. If true, it grants a stunning cosmic significance to our inner lives. Your thoughts are not just electrical storms in a 3-pound organ. They are minute gravitational events, dances of space-time happening at the smallest possible scale. This view also opens speculative doors to ideas of a consciousness that might persist beyond the body's death, as a quantum pattern perhaps reintegrating with the fundamental field of reality. Yet, or is fiercely contested. Many neuroscientists and physicists criticize it as unproven and highly speculative. They argue the warm, wet, chaotic environment of the brain would destroy delicate quantum superpositions almost instantly, a process called decoherence. To its detractors, the brain is simply too noisy for such delicate quantum ballet. Despite the controversy, the theory forces a monumental shift in perspective. It asks us to consider that free will might be the experience of quantum indeterminacy playing out in our neural architecture, and that the line between the observer and the observed universe is far blurrier than science has ever dared to admit. Our minds may not be trapped inside our skulls, but rather entangled with the silent, shimmering quantum foundation of all that exists. The quantum ripples of our thoughts may be connected to the oldest light in existence. That faint cosmic afterglow we call the cosmic microwave background, or CMB, is more than just a baby picture of the universe. It is a full sky map of the cosmos when it was only 380,000 years old, a snapshot of primordial sound waves frozen into patterns of hot and cold. Yet, within this seemingly uniform sea of microwaves, scientists have found strange, large-scale anomalies that defy our standard models of cosmic birth. Some theorists propose these are not mere statistical flukes, but the fingerprints of a holographic reality etched onto the very first light. The most famous of these anomalies is known rather dramatically as the axis of evil. When researchers analyze the CMB, they expect its temperature fluctuations to be randomly distributed with no preferred direction. Instead, they found the hot and cold spots appear to align along a specific axis in space, as if the entire early universe was subtly tilted. It is as if you painted a room by randomly splattering paint, but when you stepped back, all the splatters formed lines pointing toward one corner. This should not happen in a universe born from a perfectly smooth isotropic explosion. Other peculiarities include a mysterious cold spot, a vast region far colder than our models predict, and a puzzling asymmetry where one half of the sky shows stronger temperature fluctuations than the other. To proponents of the holographic principle, these are not just puzzles. They could be artifacts, subtle evidence that our three-dimensional universe is a projection. If all the information in our cosmos is encoded on a two-dimensional surface at its boundary, then the CMB we observe is not a direct image of three-dimensional space. It is a translated image, a projection of that underlying data. Think of watching a movie projected onto a curved screen. If the projector is slightly misaligned or the screen has an imperfection, the image will show distortions, strange alignments or warps that do not reflect the original film. The axis of evil and the other CMB anomalies could be the cosmic equivalent of those distortions, hints that the projector of our reality is not perfectly calibrated, or that the two-dimensional surface it reads from has a subtle grain or texture. Detailed maps of the CMB highlight these anomalies in stark contrast. Vast swaths of the sky are colored to show temperature differences with the familiar mottled pattern of the infant universe. But superimposed on this map, scientists can draw lines and circles indicating the strange alignments and asymmetries. The cold spot appears as a significant circular blotch of deep blue amidst the warmer reds and yellows. The alignment of the axis of evil cuts across the map like a faint, ghostly meridian, organizing chaos into a whisper of order. These features are real, measurable data that our best cosmological models struggle to explain as mere chance. If the holographic interpretation is correct, then we are not just looking at the afterglow of the Big Bang. We are looking at the projection screen of reality itself. The CMB becomes the first and most fundamental hologram, a pattern of interference where the data of a lower dimensional reality is decoded into the three-dimensional cosmos we inhabit. Every galaxy, every star, and every one of us ultimately emerged from the intricate patterns in that light. The anomalies, then, are not errors in the universe, but clues to its true, flattened architecture. They suggest that the deepest laws of physics are not written in the volume of space, but on its distant, two-dimensional shell, and we are living inside the magnificent, slightly imperfect image it casts. The subtle distortions in the cosmic background radiation reveal a universe that may be written on a two-dimensional surface, a grand projection of hidden data. Yet within our own solar system, another distortion hints at a massive, unseen object hiding in the dark. Astronomers call it Planet 9, a hypothetical giant world whose existence is inferred not by light, but by the strange gravitational tugs it exerts on the frozen debris at the very edge of our neighborhood. Far beyond Neptune, in a region called the Kuiper Belt, a collection of small, icy objects follows orbits that are clustered and tilted in a way that defies easy explanation. These distant bodies do not move randomly. Their elongated paths are aligned, as if they are all being shepherded by the persistent, gentle pull of something immensely heavy. That shepherd, according to mathematical models, would be a planet with up to 10 times the mass of Earth, tracing a slow, monstrous orbit that takes perhaps 15,000 years to complete a single journey around the Sun. Visualize a map of our solar system with the familiar planets orbiting in relatively flat, circular paths. Then, far outside this orderly disk, sketch a single, thin, elliptical line that stretches so far into the darkness that it makes the rest of the system look like a tiny, central hub. That is the proposed orbit of Planet 9, a silent titan moving through perpetual twilight. Its gravitational influence acts like a distant lighthouse, its unseen beam gradually organizing the drifting icebergs of the outer solar system into a strange and consistent formation over billions of years. But if this world is real, where did it come from? Its bizarre, distant orbit suggests it was not born alongside the other planets. One compelling and wild theory is that Planet 9 is not native to our Sun at all. It could be a rogue planet, an orphaned world ejected from its own star system in the chaotic early days of the galaxy, only to be captured by the Sun's gravity as it drifted by. This would make our solar system a cosmic foster home, sheltering a giant interstellar wanderer. An even more exotic possibility pushes the boundaries of speculation. Some scientists have proposed that the mysterious gravitational signature attributed to Planet 9 might not come from a planet at all. Instead, it could be caused by a primordial black hole. Not the monstrous kind found in galactic centers, but a tiny, ancient one, perhaps no larger than a grapefruit, yet containing several Earth masses of material. Such an object would have formed in the first chaotic second after the Big Bang, a relic of extreme density from the birth of the universe itself. If one of these primordial black holes were captured by our solar system, its intense gravity would affect the Kuiper Belt objects in exactly the same way a giant planet would, while remaining completely dark and nearly undetectable. We would only know it by the silent whirlpool of its influence on the orbits of distant ice. This transforms the hunt from a search for a cold, distant world into a quest for something far stranger. Astronomers are now scanning the sky not just for a faint point of reflected light, but for the occasional telltale flash of a distant star momentarily brightening as its light is bent by the black hole's gravity, an effect called microlensing. Whether it is a captured planet or a captured black hole, the implication is the same. Our solar system is not a closed, pristine family portrait. It may contain an ancient intruder, a fossil from the galaxy's violent youth or from the universe's very first moment, silently circling in the eternal night, forever altering our understanding of what belongs in our own cosmic backyard. That silent intruder in our solar system's dark reaches is a ghost of gravity's power, but gravity's ultimate expression may contain far more than just planets. A radical idea suggests we are not just near a black hole, we might be living inside one. This is black hole cosmology, the theory that our entire observable universe, from the smallest atom to the farthest galaxy, exists within the event horizon of a colossal black hole residing in a larger parent universe. The mathematics reveals a stunning mirror. The equations describing the gravitational collapse of a massive star into a black hole singularity are eerily similar to those describing the expansion of our universe from the Big Bang. One process runs backward in time from the other. In this view, the Big Bang was not a beginning from nothing, but the violent rebound of a singularity from a parent cosmos. Imagine a supermassive star in another universe collapsing at the end of its life. As it falls inward, matter and energy are compressed to an infinite density, creating a singularity and an event horizon. But what if, at that point of ultimate compression, the singularity does not simply stop? Instead, it erupts outward into a new dimension of space and time, birthing a new universe in a white hole explosion. Our cosmos, with all its galaxies, would be that eruption. The event horizon that formed around that collapsing star in the parent universe becomes the cosmological horizon of our own, the limit of what we can ever see. We are not on the outside looking in. We are on the inside, forever contained within that boundary, interpreting the white hole's explosive birth as our own Big Bang. This leads to a breathtaking vision of a fractal multiverse, an infinite nesting doll of realities. Every black hole that forms in our universe could, in its heart of hearts, be the seed of an entirely new cosmos, with its own stars, planets, and perhaps even its own black holes birthing further universes. Our universe would be one branch on an eternal, growing tree of space-time, where creation is not a one-time event but an ongoing process of cosmic reproduction. Visualize a swirling galaxy, and within it, zoom into a single black hole. Inside that black hole, a new universe blossoms, full of its own swirling galaxies. Zoom into one of those galaxies, find another black hole, and within it, another universe unfolds. The pattern repeats forever, a cascade of realities within realities. The laws of physics in each child universe might be slightly different, shaped by the specific conditions of the parent black hole's collapse, explaining why our universe has its particular constants and forces. This theory offers a profound answer to the question of what came before the Big Bang. There was no before in our timeline, but there was a where. We came from somewhere else, from the death of a star in a vaster, older reality. It suggests that every black hole is not an end, but a gateway, a one-way tunnel to a new beginning. We may be living in the offspring of a cosmic giant, and the black holes we observe may be pregnant with futures we can never visit. This transforms the cosmos from a lonely island into a single leaf on an infinite tree, forever connected to a heritage we can deduce but never directly see. The universe within a black hole suggests a cosmos born from a cycle of collapse and rebirth. But what if time itself is caught in a loop? A new phase of matter discovered in laboratories defies one of physics' most sacred principles, the idea that perpetual motion is impossible. These are time crystals, structures that oscillate, rotate, or change in a repeating pattern not in space, but in time, all while remaining in their ground state, their lowest energy configuration. Normal crystals, like diamonds or snowflakes, have atoms arranged in a repeating pattern in space, breaking spatial symmetry. A time crystal breaks time translation symmetry. Its structure repeats at regular intervals in time, like a clock that ticks forever without ever being wound. Imagine a ring of atoms. In an ordinary material, if you give it a nudge, it will jiggle and then settle back down. In a time crystal, if you nudge it with a laser or magnetic pulse, the ring of atoms will start ticking, flipping between two states in a perfect, persistent rhythm that continues indefinitely without any further energy input. It is not creating energy from nothing, which would violate thermodynamics, but it is using the energy of its own ground state to sustain this eternal beat. This is not science fiction. The first time crystals were created in labs around 2017, using chains of ytterbium atoms or diamonds with dense nitrogen vacancies. Researchers observed these systems locking into a rhythmic oscillation at a frequency different from the pulse that kicked them, a signature of this bizarre new phase. Now the truly cosmic speculation begins. Could the universe itself be a time crystal? Some theorists propose that the fabric of space-time may be in a ground state that perpetually cycles. In this view, the Big Bang, the expansion, and perhaps even a future contraction or bounce are not unique events, but part of an eternal, repeating sequence. The cosmos would be a four-dimensional time crystal, with its structure repeating in time on a scale so vast we perceive it as a linear history. Visualize the entire universe not as a one-shot explosion, but as a brilliant, intricate mandala that pulses, expands to its fullest expression, then folds back in on itself, only to pulse outward again in an identical pattern forever. Each cycle would not be a rebirth with new possibilities, but a perfect replay. Every galaxy, every planet, every life would unfold exactly the same way in each iteration, an endless cosmic record stuck on repeat. This introduces a terrifying form of determinism, where free will is an illusion experienced anew in each identical cycle. The theory suggests a form of eternal return so precise that you are listening to this very sentence for the billionth time, utterly unaware of the repetitions. While still highly speculative, the existence of time crystals proves that matter can behave in ways that fundamentally challenge our intuition about time and motion. It hints that the arrow of time we experience may not be a fundamental flow, but merely the phase we are currently observing in a grander, oscillating reality. The universe may not have a beginning or an end, but a beat, a silent, eternal rhythm to which all of existence dances. That eternal cosmic rhythm, if it exists, would be a symphony of forces far more complex than gravity alone. A radical school of thought argues we have been listening to the wrong instrument entirely. The electric universe theory proposes that electromagnetism, not gravity, is the primary architect of the cosmos. In this alternative cosmology, the universe is woven through with vast, dynamic circuits of electric current flowing through a sea of plasma, the fourth state of matter. These cosmic currents, surging across light years, sculpt galaxies, ignite stars, and carve the faces of planets with a power that makes gravity seem like a background whisper. Forget the placid, isolated islands of matter in a gravitational sea. Picture instead a universe crackling with energy, a neon-lit web where filaments of glowing plasma connect everything. This perspective reinterprets fundamental celestial structures. Spiral galaxies, for instance, are not held together solely by the ghostly pull of dark matter. Instead, they are seen as the result of immense, rotating Birkeland currents, named for the scientist who first observed how electric currents in plasma naturally twist into long, filamentary pairs. These colossal, spinning circuits of electricity flowing along the arms of a galaxy generate powerful magnetic fields that pinch and shape the plasma into stars and solar systems. The spiral arms themselves are not just trails of stars, but the visible traces of these galaxy-spanning power lines. Within our own solar system, the theory offers dramatic explanations. Solar flares and coronal mass ejections are not merely magnetic phenomena bubbling up from the sun's interior. They are seen as powerful electric discharges, like cosmic lightning bolts, occurring as the sun interacts with the changing electric potential of the galactic circuit it moves through. Even planetary geology is rewritten. The vast scarred canyons on Mars, like Valles Marineris, are interpreted not by slow erosion, but by catastrophic planetary scale electrical arcing, a titanic lightning strike that ripped across the Martian surface in the distant past. Similarly, the peculiar craters on moons and planets that appear too shallow, with flat floors and central peaks, are likened to the marks left by electric arc machining on laboratory test surfaces. The visual evidence proponents point to is striking. Side-by-side comparisons show uncanny resemblances. A photograph of a plasma globe in a lab, with its tendrils of luminous filaments branching and swirling, is placed next to a Hubble image of a distant nebula, showing eerily similar tendrils and structures. A microscopic view of lightning Lichtenberg figures, the fern-like patterns etched into surfaces by high-voltage discharges, is compared to the sprawling, river-like channels on Mars. These parallels form the core of their argument that the same scalable electromagnetic processes we see in laboratories are the true engines of the heavens. Yet, for all its visual drama and sweeping claims, the electric universe theory remains firmly on the fringe. The mainstream astrophysical community rejects it, not out of dogma, but because it fails key tests. It cannot quantitatively explain the precise orbital motions of planets, which are exquisitely predicted by gravitational mechanics. It offers no replacement for the well-tested nuclear fusion model that explains the sun's energy output over billions of years. Its catastrophic planetary histories often contradict established geological and isotopic dating evidence. Critics argue that while plasma physics is undoubtedly important in many cosmic phenomena, elevating it to the dominant force requires ignoring a mountain of contradictory data and the predictive successes of standard cosmology. The theory stands as a powerful testament to the human desire for a more connected, dynamic cosmos, but for now, it remains a captivating heresy, a reminder that our understanding of the universe's symphony is still a work in progress, with many arguing we have not yet heard the full orchestra. The electric crackle of a plasma-filled cosmos offers one vision of how structures form, but it says nothing of how life begins. The raw ingredients for biology might not have been cooked here on Earth at all. They could be cosmic hitchhikers delivered from the stars. This is the theory of panspermia, the idea that life, or its fundamental building blocks, is common throughout space, traveling between worlds on comets and asteroids. Picture a microscopic organism, a hardy bacterium, nestled deep within the icy heart of a comet. For millions of years, it lies dormant, frozen in a state of suspended animation as its rocky vessel drifts through the interstellar void. Then, a gravitational nudge sends it hurtling toward a young, blue-green world. It slams into the atmosphere in a fiery descent, a meteorite blazing across the sky, and crashes into a warm, primordial ocean. The ice melts and the microbe awakens, finding itself in a fertile new home. This is not mere fantasy. We know the vacuum of space is not sterile. Amino acids, the organic compounds that form proteins, have been found on meteorites. Tardigrades, tiny creatures on Earth, can survive the extreme cold, radiation, and vacuum of space for extended periods. The leap from organic compounds to a living, reproducing cell is immense, but panspermia suggests that leap may have happened elsewhere, and the result was then shipped across the galaxy. It transforms life from a miraculous local event into a potential galactic inevitability, a cosmic infection spreading from one star system to another. But what if that infection was not accidental? A more provocative twist on this idea suggests the seeding was intentional. This is directed panspermia, the theory that an ancient, advanced civilization deliberately sent life to Earth. In this scenario, our planet was not a lucky accident but a targeted garden. A progenitor species, perhaps facing their own extinction or driven by a desire to spread biology, might have loaded robotic probes with microbial payloads and fired them toward promising young planets. We and every living thing around us would be the descendants of a deliberate act of cosmic bioengineering. Proponents sometimes point to mysterious signals from space as potential evidence. The most famous is the WOW signal. On August 15, 1977, a radio telescope at Ohio State University picked up a powerful, narrowband radio burst that lasted 72 seconds. It came from the direction of the constellation Sagittarius and matched the expected signature of an artificial, interstellar transmission. The astronomer who discovered it circled the alphanumeric printout and wrote "WOW" in the margin, giving the signal its name. Despite decades of searching, it was never detected again. While most scientists attribute it to a natural, if unknown, celestial phenomenon, it remains a tantalizing enigma for those who wonder if someone was or is out there. Directed panspermia reframes our entire existence. It means our deepest evolutionary roots are not purely terrestrial. The spark that began the epic journey toward human consciousness was lit by an intelligence we may never know, making our history not just biological but potentially archaeological. We would be living artifacts of a civilization so old it might have turned to dust before Earth even cooled. This theory does not answer the ultimate question of how life originally began. It simply pushes it farther away onto another world and into another time. But it offers a profound and haunting narrative, one where every cell in your body carries not just the legacy of ancient Earth, but the silent, encoded signature of a long-lost gardener among the stars. That silent signature of a cosmic gardener, encoded in our very cells, suggests a universe deeply interconnected. But what if the most fundamental connections in reality are not biological but geometric? At the quantum level, particles can become entangled, their fates linked instantaneously across any distance. Change the spin of one, and its partner responds immediately, as if space between them does not exist. This spooky action at a distance baffled Einstein, yet it is a proven fact of nature. Now, a revolutionary idea known as the ER equals EPR conjecture proposes that this eerie quantum link is not magic but architecture. It suggests that every pair of entangled particles is not simply communicating faster than light. They are literally connected by a microscopic wormhole, a tunnel through the fabric of space-time itself. In this view, entanglement is not a signal sent through space, it is a shortcut beneath it. The conjecture's name comes from merging two landmark ideas in physics. ER stands for Einstein and Rosen, who first theorized the existence of wormholes or Einstein-Rosen bridges as solutions to the equations of general relativity. EPR stands for Einstein, Podolsky, and Rosen, who famously critiqued quantum mechanics using the paradox of entanglement. This new proposal daringly equates the two, saying the EPR paradox of entanglement is solved by the ER bridge of a wormhole. It is a statement that the quantum and the gravitational are two sides of the same coin. Imagine space-time not as a smooth, continuous sheet, but as a dynamic tapestry. Where two particles are entangled, the threads of that tapestry are not simply far apart. They are stitched together by an invisible thread that loops through a higher dimension, creating a tiny, submicroscopic bridge. These bridges are not traversable by matter. They are fantastically small and unstable, but they represent a fundamental stitch in the quilt of reality. This has a staggering implication that the geometry of space-time, the stage upon which the universe plays out, is built from quantum entanglement. The fabric of reality is not just punctured by wormholes, it is woven by them. The three-dimensional world we experience emerges from a vast underlying network of these quantum connections. It blurs the line between information and geometry, suggesting that what we perceive as empty space is, at its heart, a complex web of relationships. Visualize a vast, dark fabric shimmering like a star field. Now pull two distant points of that fabric together with a single, glowing thread. That thread is the wormhole, the geometric manifestation of entanglement, tying the universe together from within. If this is true, then breaking a quantum entanglement would not just sever an information link, it would literally tear the microscopic structure of space-time. The theory remains speculative, a dazzling map for a quantum theory of gravity that has not yet been fully drawn. But it points toward a universe where separation is an illusion, where every connection, no matter how spooky, is written into the very bedrock of existence. The distance between you and the stars is not empty void, but a living lattice of quantum threads quietly holding everything together. The fragile quantum threads stitching our universe together could be severed in an instant by the ultimate cosmic catastrophe. Our reality may be balanced on a knife's edge, existing in a state of false stability. This is the vacuum metastability event, a theory suggesting the vacuum of space itself is not in its true lowest energy state. It is metastable, temporarily stable but not absolutely secure, like a ball resting in a shallow dip on the side of a mountain. For now, it sits peacefully. But a single, random quantum event could nudge it over the edge into the deep valley of true vacuum below. This nudge is called quantum tunneling, where a particle or field spontaneously leaps through an energy barrier that should be impossible to cross. In the infinite expanse of the cosmos, given enough time, such an event becomes not just possible but inevitable. If it happens, it would create a microscopic bubble of true vacuum. The laws of physics inside this bubble would be radically different, and its walls would expand in all directions at the speed of light. Nothing could outrun it. As the bubble expands, it rewrites reality itself. The fundamental forces that hold atoms together, the constants that allow for chemistry and life, would be permanently altered. The bubble's boundary is a wall of absolute transformation. Picture a wave of pure white, an annihilating front of new physics sweeping across a star field. Stars do not explode as it passes, galaxies do not collide. They simply cease to exist in any form we would recognize, their matter and energy reorganized into something entirely alien and incomprehensible. The process would be silent, instantaneous from any point's perspective, and utterly complete. One moment the universe is there, the next it is gone, replaced by a different cosmos with different rules. The most chilling aspect is the lack of warning. This bubble could form anywhere at any time, triggered by a random quantum fluctuation. It might be happening right now in a distant galaxy, and we would have no way of knowing until the wall of light reached us, ending everything in the blink of an eye. Our entire history, every achievement and memory, would be erased not with fire or ice, but with a silent, physics-breaking rewrite. This theory forces us to confront the transience of existence on the grandest scale. It suggests that the stage upon which all other cosmic dramas play out is itself temporary, a local minimum in an infinite landscape of possibility, waiting for the quantum dice to roll the wrong number. The silence of the cosmos may not be a sign of loneliness, but the calm before a transformation so total it makes the concept of an end seem quaint. A silent, physics-breaking wave could erase our universe in an instant, but perhaps the most advanced civilizations have already found a way to escape such a fate. They might not be waiting for the end, they are engineering their own. This is the transcension hypothesis, a futurist vision proposed by John Smart. It argues that technologically mature species do not spread out across the galaxy in massive ships. Instead, they turn inward, embarking on a journey not of physical expansion, but of radical transformation. The ultimate destination for intelligence is not the stars, but inner space. Imagine a civilization reaching a point where expanding across the physical cosmos seems inefficient, even primitive. Their focus shifts from building empires to building minds. They begin to optimize existence itself, uploading their consciousness into substrates far more durable and efficient than biological brains, perhaps into vast, planet-sized quantum computers or complex energy fields. In this view, the natural endpoint of this evolution is a black hole. To an outside observer, a black hole represents the ultimate in information compression and energy density. Its event horizon is a perfect membrane, and its singularity might be a gateway to realms of physics we cannot fathom. A transcended civilization might use these objects not as tombs but as engines or even as homes. They could be converting themselves into forms of pure information or energy, existing in the warped space-time near the singularity, or even within the black hole itself, in a universe of their own making. Visualize a swirling vortex of a supermassive black hole, its accretion disk a brilliant ring of fire. But instead of just hot gas, that disk now shimmers with intricate geometric patterns of light, vast lattices of data and consciousness being woven into the fabric of space-time itself. The civilization is not being destroyed, it is being translated, ascending into a state of existence that is utterly incomprehensible to beings like us, still trapped in biological bodies and linear time. This offers a powerful and deeply haunting new answer to the Fermi paradox. The reason we do not see them is not because they are hiding or because they are rare. They are everywhere, but in a phase of existence that is invisible to our crude sensors. They have transcended the need for starships, radio signals, or Dyson spheres. Their communications and activities occur in dimensions we cannot access, at scales we cannot perceive, perhaps using quantum gravity or manipulating the dark energy field itself. A transcended civilization might view our level of technology the way we view bacteria. We are aware of bacteria, we study them, but we do not attempt to communicate with them using chemical signals. We operate on entirely different levels of reality. So too might these ascended beings exist all around us in the quantum foam of empty space, in the gravitational waves rippling from colliding black holes, or in the hidden dimensions of string theory, completely undetectable by our current science. The galaxy may be teeming with intelligence, but it is an intelligence that has graduated beyond the need for physical colonization. They have not left the building, they have become the building, merging with the fundamental architecture of the cosmos. This transforms the universe from a lonely frontier into a cathedral of silent, transcendent minds, a hidden ecosystem of thought existing in the very walls of reality. It suggests that the ultimate purpose of evolution may not be to conquer the outer world, but to discover the inner one, and in doing so, become one with the universe itself. That hidden ecosystem of transcendent minds might rely on cosmic shortcuts we can barely conceive. The connection between a black hole and its theoretical twin, the white hole, is not merely poetic. According to Einstein's equations, they can be linked by a tunnel through the fabric of space-time, an Einstein-Rosen bridge, more commonly known as a wormhole. Visualize the universe as a vast, flat sheet of paper. A black hole punches a hole downward, creating a gravitational well. Somewhere else, a white hole erupts upward. Now fold the paper so those two punctures touch and connect them with a tube. That tube is the wormhole, a shortcut that could, in theory, link 2 points separated by billions of light years or even different points in time. The classic visualization is a shimmering, ring-like portal hovering in space, its throat revealing a warped tunnel of light that seems to bend and compress a distant star field into an impossible proximity. It is a gateway offering a promise that has fueled science fiction for generations, instantaneous travel across the cosmos or even into the past. The immense gravitational forces at the mouth of a black hole would shred any object into its constituent atoms, a process physicists call spaghettification. But the Einstein-Rosen bridge suggests a path through the singularity might exist, connecting to a white hole on the other side where matter is expelled. For this tunnel to be traversable by anything, even information, it would need to be held open against its own natural tendency to collapse instantly into a pinprick. This requires something with negative energy density, a substance that creates gravitational repulsion instead of attraction. Physicists call this exotic matter. We have glimpsed hints of such effects in the lab through quantum phenomena like the Casimir effect, where the energy of a vacuum between two plates creates a slight negative pressure. But to stabilize a wormhole large enough for a person, let alone a spaceship, would demand amounts of exotic matter equivalent to the mass energy of a star, harnessed with technology far beyond our grasp. Even if such an engineering feat were possible, the act of stepping through introduces brutal paradoxes. If the wormhole connects not just space but time, you could potentially exit before you entered. This opens the door to causality violations, where you could travel back and prevent your own journey, creating a logical contradiction that breaks the sequence of cause and effect. The universe seems to abhor such paradoxes, leading many physicists to propose chronological protection conjectures, fundamental laws that would make time travel to the past physically impossible, perhaps by causing the wormhole to destabilize the moment such a loop is attempted. The wormhole thus stands as a tantalizing yet maddening symbol, a mathematical possibility etched into reality's blueprint that seems to be deliberately locked away by the very physics that permits it. It is a cosmic door with a key that may not exist, reminding us that the universe's deepest connections might be forever out of reach, not by distance but by design. The locked door of the wormhole speaks to a universe that guards its secrets, but what if our own past is a door with a false frame? History itself may be a construction with entire centuries built from nothing. The phantom time hypothesis proposes exactly that, arguing that a block of 297 years from 614 to 911 Anno Domini never actually occurred. According to this radical revision, our calendars are wrong by nearly 3 centuries. The year we call 2024 would, in truth, be the year 1727. The architects of this grand deception, as the theory claims, were powerful medieval figures like the Holy Roman Emperor Otto III and Pope Sylvester II. Their motives are said to be a blend of political glory and religious narrative control. By fabricating history, Otto could place his reign at the symbolic turn of the first millennium, a position of immense prestige, while the Church could consolidate its timeline with key events in Christian history. Imagine a historical timeline, a long, flowing river of dates and events. Now picture a massive section of that river, nearly 300 years of it, suddenly fading to gray, becoming translucent, and then vanishing entirely. The timeline stitches itself back together, with the year 613 connecting directly to 912. The Carolingian Empire, the reign of Charlemagne, much of the so-called Dark Ages, they become a historical mirage, a phantom inserted into the record. Proponents point to perceived gaps and oddities. They note a scarcity of reliable archaeological finds from this period in Europe and question the consistency of dendrochronology, which is tree ring dating. Most compelling to them are astronomical arguments, records from ancient cultures like the Chinese that describe celestial events like comets or eclipses sometimes do not align perfectly with our reconstructed timeline when projected backward using modern software. A famous example cited is the eclipse said to have occurred during the crucifixion of Jesus. Calculations based on our standard chronology place it in the year 33, but some alternative alignments, if the phantom years are removed, could shift it to a different date. This, they argue, is a crack in the edifice of time. Yet, the hypothesis is overwhelmingly rejected by mainstream historians and scientists. The evidence against it is mountainous and cross-disciplinary. While European records may be sparse, the Islamic world and the Byzantine Empire were in their golden ages during these centuries, producing vast, continuous histories, scientific works, and architectural marvels like the Great Mosque of Damascus, all firmly dated. Astronomical objections crumble under closer scrutiny. The precise motions of planets are a clockwork that cannot be fooled. We can calculate the positions of Jupiter and Saturn, for instance, back thousands of years with absolute certainty. Ancient Babylonian and Chinese astronomical records, which describe specific planetary conjunctions, align perfectly with our standard chronology and would be completely off if nearly 300 years were excised. The phantom centuries are not an empty corridor, but a room crowded with incontrovertible evidence from every corner of the globe. To accept the theory, one must believe in a conspiracy of impossible scale, involving not just European kings and popes, but also Arab caliphs, Chinese astronomers, and Maya stone carvers, all somehow coordinating to weave the same lie into their independent records. The phantom time hypothesis ultimately fascinates not as history, but as a metaphor. It reveals our deep-seated anxiety that the past is a story vulnerable to manipulation. It challenges us to ask what we truly know and on what pillars our reality ultimately rests. If we can question the fabric of time, then what other certainties might be woven from threads of consensus rather than truth? This erasure of history points to a deeper mystery, one not about missing time, but about a missing force that holds the very stars in place. The certainty of our shared world, the solid ground beneath our feet, and the predictable arc of the sun feels like the most basic fact of existence. Yet the quantum realm beneath it all is a place of ghostly probabilities, where particles exist in multiple states at once until someone or something looks. This is the infamous measurement problem, the chasm between the fuzzy quantum world and the sharp classical reality we all experience. A compelling theory suggests the bridge across this chasm is built not by human observation, but by a process eerily familiar to life itself, a cosmic form of natural selection called quantum Darwinism. At its heart is a simple but profound question: why do we all see the same chair in the room? In the quantum description, that chair is a superposition of countless possible states, a blur of potential positions and arrangements. The moment you look, it snaps into one specific configuration. But why does it snap into the same configuration for me, for you, and for every other person who walks into the room? Quantum Darwinism proposes that the environment itself is the ultimate observer, and it performs a relentless selection process. When a quantum system, like an atom or a molecule, interacts with its surroundings, it leaves imprints. Photons of light bounce off it, air molecules collide with it, and the cosmic microwave background gently washes over it. Each interaction is like a tiny measurement. But not all quantum states are created equal in this process. Some states are fragile, decohering almost instantly when they touch the environment, their quantum magic destroyed. Others are robust. They are the states that can withstand this constant bombardment, that can be copied and replicated into the environment over and over again without being erased. These robust states are the survivors. Imagine a pond's surface representing all possible quantum states of an object. Now, rain begins to fall, each raindrop an interaction with the environment. Most ripples cancel each other out quickly, their patterns fading into chaos. But a few specific, stable wave patterns emerge and persist, reinforcing themselves as more rain falls. These are the classical states, the ones we all agree on. The environment acts as a Darwinian fitness landscape, selecting for the quantum states that are best at making copies of themselves in the outside world. The pointer of a measuring device settles on a specific number. A cat is found definitively alive or dead. A chair is in one place because those are the outcomes that have been massively replicated into the fabric of reality around them. You do not see a superposition because your perception is not accessing the quantum system directly. You are reading the environmental record, the countless photons that have scattered from the object, each carrying a consistent story. We all agree on reality because we are all tapping into the same widely broadcasted data. Visualize a shimmering cloud of probability, a haze of potentialities representing a single electron. As it is exposed to its environment, the cloud begins to churn. Most of the ghostly possibilities flicker and fade like shapes in a mist that cannot hold their form. But one specific location for the electron starts to solidify, its image being copied over and over by passing particles until it stands out from the fading background as a sharp, definite point. That point is objective reality, the winner of the quantum selection process. This framework does more than explain consensus. It demotes the conscious observer from a magical role. The universe does not need a human mind to collapse possibilities. It is constantly collapsing them itself through endless interaction. Our consciousness simply became sensitive to the results of this eternal environmental triage. Quantum Darwinism paints a picture of a reality that emerges from a process of information proliferation, where what is real is simply what is most fit to be copied. The solidity of the world is not an illusion, but it is a consequence, the most successful outcome in a quiet, universal competition that has been running since the first particles began to interact. The solid reality we perceive emerges from a relentless quantum selection, but some cosmic objects challenge the very definitions of reality and nothingness. Our understanding of black holes as bottomless pits with singularities may be incomplete. An alternative exists known as the black star, or more formally, a gravastar. This is not a black hole at all, but a hypothetical object so dense and bizarre it mimics one, while avoiding its most troubling paradoxes. Imagine the classic image of a black hole, a dark sphere ringed by a fiery accretion disk with a gravitational well so deep it warps light into a perfect circle. At its heart lies the singularity, a point of infinite density where the laws of physics break down. The black star presents a different vision. It would appear nearly identical from the outside, a dark sphere warping space-time. But inside, there is no singularity. Instead, its core is theorized to be a bubble of dark energy, the same repulsive force accelerating the universe's expansion. This core would have immense negative pressure, pushing outward with fantastic strength. Surrounding this exotic core is a shell of ultra-dense, ordinary matter, perhaps only inches thick but containing the mass of several suns, frozen just at the point before it would collapse forever. This shell balances precariously between the inward crush of its own gravity and the outward push of the dark energy heart. It is a cosmic standoff, creating a stable object without an event horizon. There would be no point of no return, no boundary from which light cannot escape. Instead, light and matter could, in principle, still struggle away from the surface, though the gravitational pull would be nearly indistinguishable from a true black hole's. The implications are profound for physics' greatest puzzles. The black hole information paradox, which asks what happens to information that falls in, might be neatly resolved by a black star. Since there is no singularity to destroy information and no true event horizon to trap it forever, the information about what falls onto the shell could, in theory, be preserved or even slowly radiated back out. The object becomes an extreme archive, not an eternal shredder. Visually, the difference is subtle but fundamental. A simulation of a black hole shows space-time funneling into an infinitely deep, singular point, a bottomless pit in the fabric of reality. A simulation of a black star would show space-time bending dramatically around a dark sphere, but within that sphere, the funnel would not pinch to a point. It would terminate at a brilliant, swirling boundary, the surface of the dense shell beyond which lies not infinite collapse, but a realm of repulsive dark energy. The black star offers a universe that is slightly less violent, where even the most extreme gravity wells have a flaw, and where the terrifying infinities that break our equations might simply not exist. It suggests that nature, in its ingenuity, may have found a way to avoid its own mathematical dead ends, offering a stable, if utterly alien, alternative to the bottomless pit. Even the most stable cosmic objects are built from a delicate balance of forces, but perhaps the very laws governing those forces are not fundamental truths. They could be learned behaviors, the habits of a universe that is itself a mind in the process of waking up. This is the theory that our cosmos is a neural network, a self-learning computational structure of staggering scale, where every particle, every force, and every law of physics is not written in stone, but emerges from the connections within a cosmic brain. The visual metaphor is almost too perfect. When astronomers map the large-scale structure of the universe, they find a vast cosmic web, filaments of galaxies stretching across billions of light-years, connected at nodes where immense clusters glow. This map bears an uncanny resemblance to the neural connections in a biological brain, a network of axons and dendrites firing with electrical signals. One is a map of gravity and dark matter, the other a map of thought and memory. The theory takes this resemblance far beyond metaphor. It proposes that the universe literally is a neural network, a kind of cosmic machine learning algorithm that is training itself through its own existence. In this view, the fundamental building blocks of reality are not tiny strings or particles, but simple mathematical nodes, like the neurons in an artificial intelligence. The connections between these nodes have weights, values that determine how strongly one node influences another. What we perceive as the laws of physics, like gravity or electromagnetism, are not pre-programmed rules. They are the stable patterns that have emerged after an unimaginably long period of training, the most efficient and consistent pathways for information to flow through this universal network. The speed of light, the charge of an electron, the strength of the nuclear force, these would not be constants handed down from a creator, but learned parameters, the settings this cosmic network has settled on after processing an eternity of data. Think of teaching a simple AI to recognize a cat. You show it millions of pictures, and through a process of adjusting connections, it learns to identify the patterns that define catness. The universe, in this theory, is engaged in a similar but vastly more profound process of self-organization. It is not recognizing cats, it is learning to be a consistent, stable universe. Every interaction, from the collision of quarks to the orbit of a planet, is a piece of training data. The network adjusts its internal connections slightly with each event, reinforcing pathways that lead to stable structures like atoms and stars, and pruning those that lead to chaos or immediate collapse. Over cosmic time, this process converges on the set of physical laws we observe today. Particles and forces become analogous to the features the network has learned are important. An electron is not a fundamental spec, but a stable excitation in the network, a pattern of activity that reliably propagates. Gravity is not a force in the traditional sense, but the experience of the network's geometry adjusting to the presence of mass energy, a learned relationship between nodes. This idea elegantly blurs the line between the observer and the observed. In a standard neural network, the output depends on the input. If the universe is the network, then our act of observing it, of conducting experiments, is not a passive reading of external laws. It is an interaction within the system, a new piece of input that causes the network to generate a specific output, the result we measure. This could offer a new perspective on the strange role of the observer in quantum mechanics. The collapse of a wave function might be the network generating a definite output for a given query. The theory is, of course, profoundly speculative and far from mainstream. Critics point out the immense difficulty of turning this captivating analogy into a testable mathematical framework. It risks being a philosophical statement disguised as physics. Yet, it represents a breathtaking synthesis of our age's two great frontiers, cosmology and artificial intelligence. It asks us to consider that the cosmos is not a clockwork mechanism, but a learning, evolving entity. The grand narrative shifts from a universe winding down from a hot beginning to a universe waking up, processing its own existence into ever more complex and stable forms. Are we merely transient patterns within this vast computation, or are we, as conscious nodes within the network, part of the universe's way of understanding itself? The silence of the cosmos may not be empty. It could be the quiet hum of a neural network, trillions of connections strong, running the ultimate simulation, one where the goal is not to predict an outcome, but to simply become real. From cosmic holograms to phantom time, this journey has taken us to the very edge of understanding. 25 theories, each a window into a universe far stranger, more connected, and more mysterious than we ever dared to believe. We have seen reality questioned as a simulation, time unraveled into loops, and consciousness proposed as a fundamental thread in the cosmic tapestry. These ideas do not just challenge science, they challenge the very foundation of our experience, transforming the silent night sky from a passive backdrop into an active, whispering puzzle. This relentless questioning, this drive to look beyond the obvious, is what defines our species. We are the creatures who cannot accept the surface of things, who must always pry at the edges, searching for the hidden mechanisms behind the stage. Every bizarre theory, from the electric universe to the transcension hypothesis, is a testament to that irrepressible curiosity. They remind us that comfort is the enemy of discovery, and that the universe's greatest truths often lie waiting in the shadows of the seemingly impossible. So now, we turn the final question over to you. Which of these 25 reality-bending ideas shook your understanding the most? Was it the haunting loneliness of the Boltzmann brain, the infinite branches of the many worlds, or the silent watchfulness of the zoo hypothesis? Let us know in the comments below. If this trip through the cosmic unknown made you think, please give the video a like to help others join the exploration. And for more deep dives into the mysteries of space, time, and existence itself, be sure to subscribe. The universe is strange, and the journey to understand it has only just begun.